Hello students, this is a video on the QA topic test available on Bodhee Prep. The idea of these tests is once you cover a concept, the basic concepts of a topic, you refer to this test and get an idea of whether that topic is closed for you or not, whether you're able to do those questions in the exam or not. With every test, there is a video which gives you the solutions and a brief analysis of what would have been a good attempt in that test. There are more than 200 such topic tests available on our Bodhee Prep Android app. The link for the app is in the description. So make sure you download the app and make the most of these tests. This video specifically is on probability test number 5. In terms of analysis, I think easy to moderate paper, 7 questions out of 10 in about 20 minutes would give us a 95 plus percentile. If we look at the questions, in a plane, 5 lines of length 2, 3, 4, 5, 6. 5 lines are there. What is the probability that by joining the 3 randomly chosen lines, end-to-end a triangle cannot be formed? Now, total number of selections will be 5 lines are there. For a triangle, I need 3 lines. So 5C3, which is 5 into 4 upon 2, which is 10. When will a triangle not be formed? Triangle not be formed. These become the favorable cases in our question. This will happen when the sides are 2, 3, 5. Sum of two sides has to be greater than equal to the third side. 2, 3, 6. 2 plus 3 is less than 6. 2, 4, 6. 2 plus 4 is equal to 6. 2, 5 is more than 6. 3, 4 is more than 6. So for these 3 cases, we will not get a triangle, and therefore the probability becomes 3 by 10. 3 favorable cases where we are not getting a triangle upon 10 total number of cases. In terms of level of difficulty, this is an easy question, not more than a minute and a half probably to solve this question. There are 7 boys, 8 girls in a class. A teacher has 3 items: pen, pencil, or eraser, each 5 in number. He distributes the items 1 to each student. 3 items, 5 in number, 5 3s are 15, 7 plus 8, 15. What is the probability that a boy is selected at random and that person has a pencil or an eraser with him? Now, what is the probability of selecting a boy? There are 15 people, 7 are boys, so probability of selecting a boy at random is 7 by 15. The person selected, what is the probability that they will have a pencil or an eraser? Probability of a person having a pencil or eraser. There are 5 pens, 5 pencils, 5 erasers. So 10 out of 15 is the probability of having a pen, pencil, or an eraser. What is the probability that both the things happen? A boy is selected at random and he has a pen, pencil, or eraser. And so we multiply 7 by 15 into 10 by 15. This becomes 2 by 3. And therefore, 14 upon 45. 7 2s are 14. None of these becomes the answer. Again, in terms of level of difficulty, I'd say is moderate question. The question looks a little difficult. Otherwise, solving should not be too big a problem. 5 army men are standing in a row left to right. 1, 2, 3, 4, 5. Chetan, Chetaka, chariots. Shailendra, Surendra, soldiers. Dinesh is the doctor. Dinesh always stands in the middle, so let us fix Dinesh here. The 2 soldiers and 2 charioteers do not stand next to each other. So one soldier here, one soldier here, one charioteer here, one charioteer here is how they will stand. If Shailendra is not standing immediately next to a doctor, so Shailendra could either be standing here or Shailendra could either be standing here. These are the 2 positions, not immediately next to the doctor. Then out of all the arrangements possible, what is the probability that the charioteer stands next to the doctor? We know that the 2 soldiers cannot stand together, and therefore this person has to be a charioteer. Uh, in this case also 2 soldiers cannot stand together. So with Shailendra, there has to be a charioteer. And therefore, no matter what the case is, a charioteer will always be adjacent to the doctor. So this event always happens. Something that always happens has a probability of 1. I think this is an easy question. We just have to make the arrangement, and two basic arrangements give us the output. So about a minute and a half to solve. There are 3 concentric circular strips on a dart, something like this. The probability of hitting the innermost lamina is 1 by 9. The probability of hitting the central strip is 1 by 3. Outer strip is 5 by 9. Points are 10, 6 for the central, 2 for the outer. 10, 6 and 2. What is the probability of getting at least 20 points in 3 attempts, given that the target is never missed? At least 20 points. 20 points can happen if in attempt 1, 2, 3, we hit 10, 10, 10 points. Or we hit 10, 10, 6, 10, 6, 10 arrangements for this, 6, 10, 10. We could also have 10, 10, 2, 10 to 10 arrangements, 2, 10, 10. Any other thing? 10, 6, 6, 6, 10, 6, 6, 6, 10. So either all the 3 are 10s. If 2 are 10s, I can have a 6 or a 2. If 1 is 10, I need at least 10. So both have to be 6s. So these are the 10 ways possible. This can happen in hitting 10 has a probability of 1 by 9. So 1 by 9 into 1 by 9 into 1 by 9. 1 by 729. For each of them, so I'll say 3 ways possible. For each of them, 10. For 10, we need 1 by 9, 1 by 9. For 6, we need 3 by 9, 1 by 3. So this becomes 9 upon 729 for these 3. For these 3, we will have 3 into. For 10 and 10, we need 1 by 9, 1 by 9. For 2, we need 5 by 9. So 15 upon 729. These 3 are done. For these 3, we have 3 into. For 10, we need 1 by 9. For 6 and 6, we need 3 by 9 and 3 by 9. This becomes 27 by 9. 729. Either of these will happen. So the overall probability will be 1 by 729 plus 9 by 729 plus 15 by 729 plus 27 by 729. 30, 42. This becomes 52 by 729. Hence option 3 becomes my answer. Again, in terms of level of difficulty, I would say medium level of difficulty, about 2 minutes to solve. I'm keeping this for the next question. The next question says, in the previous question, if hitting any of the 3 strips had equal probability, the probabilities here become equal. 1 by 3, 1 by 3, 1 by 3. Now, in this case, total outcomes possible. So we do not need this anymore because the probabilities are now same. Total outcomes are in the first attempt, we could have hit any one of 10, 6, 2. In the second attempt, we could have hit any one of 10, 6, 2. In the third attempt, we could have hit any one of 10, 6, 2. So there are 27 total outcomes possible. Out of this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 become favorable outcomes, which will give us a sum of more than 20. Hence, the probability becomes favorable outcomes upon total number of outcomes 10 by 27. This question, because probabilities are not involved with just counting cases, becomes, I think, an easier question. Solving time definitely decreases. A locker at the RBI building can be opened by dialing a fixed 3-digit code 123 000999. Chota Chetana terrorist only know the number is a 3-digit number and has only 1 6. One of the number is 6. Could be here, could be here, could be here. This is what Chota Putta Chetan knows. Using the information, he tries to open the lock by dialing 3 digits at random. The probability that he succeeds is now a number starting with 6 having 000999. Here there are 9 options. Any digit from 0 to 9 except 6 can be used. Here there are 9 options, so there will be 81 such numbers. Similarly, here 9 options, here 9 options, 81 such numbers. 9 options, 9 options, 81 such numbers. So total there are 243 numbers possible, 3-digit numbers which will have 1, 6 and 0 can also be used in the first place. Out of these, exactly one number will be correct or their code, and therefore the probability becomes 1 upon 243 of success. Out of the 243 possibilities, one is the favorable case. I think easy question, not more than 2 minutes to solve. A pair of fair dice are rolled together till a sum of 5 or 7 is obtained. Probability that sum of 5 happens before 7. Probability of a sum of 5 will be, for 5 we need numbers 1, 4, 2, 3, 3, 2, 4, 1. So probability of a sum of 5 will be 4 by 36. 2 dice means total outcome 6 into 6. Probability of a sum of 7 will be, for 7 we can have 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. 6 cases, 6 by 36. These are 10 cases done. Therefore, probability that the sum is neither 5 nor 7 will be 36 minus 4 minus 6, that is 26 by 36. Total 36 outcomes, out of which 4 are these, 6 are these. So remaining 26 will not have a sum of 5 or 7. Now, if we want to get a sum of 5, what can happen is 5 sum turns up, or neither 5, neither 7 turns up and then 5 turns up, or in the first try, neither 5, neither 7 turns up. In the second, neither 5, neither 7 turns up. And then 5 turns up, and so on infinitely. P of 5 is 4 by 36. This becomes 26 by 36 into 4 by 36. Plus, this becomes 26 by 36 into 26 by 36 into 4 by 36. And so on. So we get an infinite GP, the sum of which will be first term upon 1 minus R. So this becomes 4 by 36 upon 10 by 36, or 4 by 10. 0.4, option 2 becomes the answer. I will call this question a moderate to difficult question. If you know what is happening, it is a doable question. Otherwise, can be a little tricky. Easily 2.5 minutes to solve. I will keep the solution with me and go on to the next question. The next is, in the previous question, what is the probability of getting a sum of 7 before 5? 5 before 7 happens in 0.4 ways. The opposite, that is 7 before 5, will happen in 1 minus 0.4 or 0.6 ways becomes the answer. Having solved the previous question, this becomes an easy question, not more than a minute to solve. Numbers are selected at random, one at a time, from 00 to 99 with replacement. An event E occurs if and only if the product of the 2 digits selected is 18. 18 means 2 into 29, 36, 63 and 9. 4 options are there. 92. If 4 numbers are selected, the probability that E occurs at least 3 times with replacement. Probability of getting a product as 18 will be 4 out of 100, because 100 numbers are there. 4 are favorable, therefore 1 upon 25. Therefore, probability of getting a number which does not have a product of 18 will be 1 minus 1 by 25, 24 by 25. We want E occurring at least 3 times. So E will occur 3 times, or therefore plus E will occur 4 times. At least 3 means 3 or 4. 3 times 1 by 25, 1 by 25, 1 by 25 into 24 by 25. 4 times one more thing that we need to do here is, when we are talking of P happening 3 times, we could have this number in any order. So this could be this, or the second number, sorry, the third number not being E, or the second number not being E, this is one, or the first number not being E. So for exactly 3 times, 3 of them are product 18, one is not. That one could be in the first place, second place, third place, or fourth place. Plus, for 4 times, we'll have just one case where all the numbers are chosen from the 4. So we get 24, 24, 24, 24, 96 plus 1, or 97 upon 25 raised to power 4. This value I'm calculating using the calculator comes out to 390625. Option 1 becomes the answer. In terms of level of difficulty, probably moderate. About 2 minutes to solve, because again 25 raised to power 4, we will always have the calculator to calculate. 100 identical coins, each with probability P, showing up heads are tossed. P lies between 0 and 1. The probability of heads showing on 50 coins is equal to heads on 51. Probability of 50 heads out of 100 tries will be given by, this is a binomial event, therefore 100 C 50, P raised to power 50, probability of success, upon into 1 minus P, probability of failure raised to power 50. Probability of 51 heads will be 100 C 51, P raised to power 51 into 1 minus P raised to power 100 minus 51, or 49. This is equal. So we write 100 factorial upon 50 factorial, 50 factorial, into P raised to power 50 into 1 minus P raised to power 50 is equal to 100 factorial upon 51 factorial into 49 factorial into P raised to power 51 into 1 minus P raised to power 49. 100, 100 cancel. 50, 51, 49 factorial 50, P 50, 50, 51, 49, 50. So we are left with 1 minus P by 50 is equal to P by 51. So 51 minus 51P is equal to 50P, or 51 is equal to 101P, and therefore P is nothing but 51 by 101. Again, the process is standard, and therefore I'm saying easy to moderate question, about 2 to 2.5 minutes to solve. So if you look at the overall, easy to moderate, 7 questions in about 10 minutes. For me, my 7 questions will be 1, 3, 4, 5, 6, 9, 10. Which are these? Definitely doing this is counting 3 cases, small numbers. I'm not counting this question as a direct question because, at least on first reading, it does not strike out rightly. That is what happened with me. This I think was an easy question. Definitely counting this. This also took some time in terms of calculation, but not a difficult question per se. The second part of it is easier. So counting that. This again was just counting 3-digit numbers with 1, 6. Definitely doing this question. This I think will not be one of the 7 easier questions. So I'm not counting 7. And since I'm not counting 7, I cannot count 8. They were the same solutions. This I think was a doable question. Just the fact that uh, uh, basic error should not happen of forgetting the order of E. This I think also was doable question because the process is standard. So for me, my 7 questions will be 1, 3, 4, 5, 6, 9, and 10.